Hi, everybody. Problem 206 out of the GMAT Wiley book. 7 pieces of rope have an average arithmetic mean of 68 centimeters and a median length of 84 centimeters. If the length of the longest piece of the rope is 14 centimeters, more than 4 times the length of the shortest piece of rope, what is the maximum possible length in centimeters of the longest piece of rope? Okay, so let me see if I can get this. Well, I don't know if I can get this all on one little thing here, but so look, you have 7 pieces of rope, and it goes on to talk about the median length. Median length is 84 centimeters. Everything's in centimeters, so I'm not going to write that each time. The nice thing about a median, when you have there's 7 pieces of rope, that means if you were to lay them out in ascending order, so this is the middle one. What's nice about this is that 1, 2, 3, 1, 2, 3. So you have 3 on each side, so that's 6 plus the middle one is 7 pieces of rope. These are laid out in ascending or increasing length. Okay? And the middle one, or the median, is 84. Okay, so then they also say a couple other things here. Let's color code this. Let's call the little one X. It says, let's go back to the problem. 7 pieces of rope have an average length of 68 centimeters. We'll come back to that in a second. And a median length of 84. If the length of the longest piece, so here's the longest piece here. Okay, I'll call it long L. And we're going to make an equation here. The longest piece is, I'll read the sentence. If the length of the longest piece of rope is 14 centimeters more than 4 times the length of the shortest piece, which we called X, what is the maximum possible length instead of the longest piece? So this is key. So L here can also be, well, I'll just leave it as L, because L is also this, okay? And then what about this thing here about the average? They have these 7 pieces have an average length. All right, so that's the length. And then it says the average length is 68 centimeters. So how do we get an average, right? When if we have, let me set a label. Say we labeled each strand A, B, C, D, E, F. So you'd add them all up, right? A plus B plus C plus D. There's 7 plus E plus F. That's 6 plus G. Each piece divided by 7. How many pieces? That would give you your average, right? Well, notice that if we take this 7 and we multiply it up here, what do we get? Well, the average is 68 times 7. There's no calculator, so you have to learn how to do this. 7 times 8 is 56. Carry the 5. Keep the 5 in mind. 7 times 6 is 42, plus 5 is 47. So this is the total length of all strands. Okay? And now, look, here's the issue where it gets a little conceptually slightly more challenging. Let me choose a nice color for here, yellow. Look at this. What is the maximum possible length of the longest piece? Well, we have these constraints here, okay? The constraints are that this is a definite number, that this is the smallest strand, and that the largest strand is governed by this equation here. But aside from that, we can do whatever we want. So and also the total amount of all the pieces is this 476. So how do you maximize this but stick to all of this? Well, you want to try to minimize the way you maximize this is you minimize all other pieces, right? If you make them, because they've got a total to this, if you make every other piece as small as possible, then that'll allow the largest to be as large as. And how would you do that? Well, if this is the smallest, let's just keep these just the same size, just as short. Okay? Then it jumps to the median, and then the way to keep these two the smallest possible is have them as close to the median as possible, and in fact, keep them the same as the median. Okay, I hope that's the conceptually tricky part. That, let me get some color on this. That the way that you maximize the longest piece of string is that you make the others as small as possible. These can all be very short, and then this has to be 84, and these two can also be 84, but they can't be less because that would put them on the other side, and then this would not be the median anymore. So, and now you add all those up and set it equal to 476. So you have x plus x plus x plus 3 times 84 plus L equals 476. Come over here, and keep in. See what L is too. We're gonna put that L in here. So what is this? This is 3x plus, what is this equal to here? 12. Carry the 1. 24, 25. Okay. And instead of L, it's 14 plus 4x from up here equals 476. Now look, you've got 3x and 4x, that's 7x. 252 and 14 is 266. That has to equal 476. And when you take 266 away from each side, the ones column is 0. 7 minus 6 is 1. 4 minus 2 is 2. Divide by 7, 21 over 7, it's 3, 0. So the shortest, but what they're asking here, if you look at the question, what is the maximum possible length of the longest piece? So if this is 30, the longest piece is governed by this. 14 plus 30, right? 4 times 30 is 120, plus 14, 134. Okay, which is here, answer D. Having a little fun with it. 134. There you go.